Hello, everyone. Welcome to this session on how to migrate from Oracle to Databricks SQL. I'm Laurent. I will be your host for 40 minutes. Before we start, quick forward-looking statement to mention that everything that you will hear, see, is subject to change. You will be able also to complete this survey at the end of this presentation. So, first of all, who am I? I work at Databricks as a specialist solutions architect, and I'm specialized in all of these questions around data warehouse migrations. And prior to that, I worked more than 15 years with Oracle database solutions in various roles, DBA, consultant, architect. And I also worked in various industries. If you want to connect, this is a QR code to my LinkedIn profile. So in this presentation, we will be focused on three main aspects. And the major part of this presentation will be focused on part one and part two. First of all, we will describe the importance of building a strategy and plan your migration, and we will see how we can do that by using multiple approaches and techniques. Then we will be focused on all of these questions and concerned about Oracle migrations and the specifics, whether it's on data movements and conversion, whether it's data types or code. And finally, we will wrap up this presentation on showing the benefits of migrating from Oracle to Databricks. So, first of all, when you migrate your data warehouse from Oracle to Databricks, Oracle is a legacy data warehouse. It's an expensive solution, and at Databricks, we are seeing more and more customers who want to migrate and to move their workloads out of this Oracle and move them to Databricks. So when we are speaking about Oracle, we have two main types of solutions. We have this one that is based out of and rely on the RDBMS solution. So you have installed Oracle or Oracle clusters on standard clusters. And you can also have Oracle installed on Exadata appliances. But for both of these solutions, the first one, as it is a solution based on an RDBMS, scaling is something that is usually complex to do, especially if you have more and more data and more workloads to address. And on the right-hand side of this slide, this Oracle Exadata is a solution that based on an appliance, which is really expensive in terms of hardware as well as software, because you have a lot of options and a lot of CPU to cover. And you have also this concern of forced renewal. So when we are speaking about moving from Oracle to Databricks, we are usually seeing this in the scope of moving data to scale up the capacity of your data sets to the cloud. And that's a good point. And also to scale your ETL because of the previous elements that I presented just before. But it's also an opportunity for you to do way more. The first of all of this opportunity is to improve your business by adding new usage, new use cases. It's also an opportunity for you to change your data architecture from legacy data models, Kimball, Data Vault, to the Lakehouse. But even if it's an opportunity to change this data model, you have also you can keep these models within Databricks, no problem on that. It's also an opportunity to enrich your data by adding new modern data sources. For example, if you want to add some Salesforce data coming from Salesforce, for example, or other data source, which is quite a bit challenging with Oracle. It will also help you to, it will be also an opportunity for you to enable new use cases based on predictive and ML use cases, but also prescriptive analytics, and prescriptive analytics will be able to be done by using GenAI capacity of Databricks. And last but not least, it's also an opportunity for you to remove all this technical depth that you acquired, you accumulated on this Oracle database. This one is very important when you think about migrating out of Oracle and more broadly data warehouse solutions. So, but before doing that, you will have to build a plan, and you will have to build a strategy to migrate out of Oracle, because, yeah, it's not something simple to do. And in terms of approaches, at Databricks, we are usually seeing 3 of them. The first one is the lift and shift approach. What does it mean? Lift and shift means that you will lift and shift your use case from a solution to another one. You will not add new use cases, new usage. The architecture will remain the same, and the ETL logic will remain the same, will also remain the same. So it's a lift and shift. You move your solution, your use case, your architecture as it is to Databricks. At the opposite, you have this modernization approach. What does it mean, modernizing to Databricks? It can mean that you will restart from scratch all the ingestion of your data, the ETL process and the architecture by adapting to the lakehouse and using Spark and so on to transform your logic. But it can be also adding some new use case. For example, if you want to keep your data coming from Oracle and add some new usages. For example, if you want to implement ML, or if you want to implement real-time decision-making use case, it's the path to choose. And in between, you can also lift and shift and then modernize. 2-step approach. And this one can be useful, for example, if you have a strict deadline in terms of license renewal, so you want to go fast to lift and shift, and then you will add some new use case. And it's also a path that you can consider depending on your needs, depending on your timelines, and what you want to achieve. So now we have this in mind. We have to choose a strategy to build a plan. And usually, every data warehouse, they are hosting descriptive analytics use cases. And all of these use cases, and because it's a data warehouse, it will support decision making. So what we usually recommend is to make first an inventory of all the business cases that lives into your data warehouse, first of all. And then this business case will act as the atomic unit of migration, of the whole migration. And it will also help you to define dependencies between them and then build to prioritize, you will be able to prioritize the migration process by migrating the first use case and then the second one and so on and so forth. But for each business case that you will inventory, the other things that you have to do is to make another inventory for each business case. You will, you will make the inventory of all the ETL process and the code logic that are associated with this business case, as well as all the Oracle database artifacts that you use for each of these business cases. It could be table, index types, material as you, and all the objects that you know, but also data types, whether they are built-in data types or user-defined data types, stored procedures if you have them, and also very important external procedure we all know that this is something that can exist in Oracle database. And making this inventory will help us to build the strategy, first of all with the business case, and then apply the migration strategy on top of this objects. So how to do that with Oracle? So at the top level, we have the business case because it's our atomic unit. And this business case can live into a database or a pluggable database, depending on your architecture. And you will find all of this information in these views in the Oracle dictionary. And for each of these business case, you will probably have your data within a schema that will, and in this schema, you will find different objects, whether it's table, indexes, and so on. So all of this is available in these tables or views. And for each object, you will have some data types, whether they are built-in. And for the built-in data types, you will find them into the DBA tab columns, and data types for user-defined data types. So this is for the Oracle artifacts. Then the ETL. So ETL process can live directly into within the database. So it will take the form of stored procedure functions or packages. All the code is available in DBA source view. Or if you use a third-party ETL, it will be in this solution. It could be Informatica, DataStage, ODI, or else. And to assess the complexity of all of these artifacts, at Databricks, you can use the profilers. So the profilers will help you to estimate the run rate once the workload will be migrated to Databricks. And Databricks Lake Bridge, and the specific part of the Lake Bridge solution, that is the analyzer, that will help you to estimate the code complexity that lives either in Oracle installed procedure or externally if it's used in, let's say, DataStage or ODI. Then, so remember we have this list of business case. We've established the priority of all of these business case. And we will not decommission the Oracle data warehouse as a single operation. We will do that step by step. And the step will be represented by the business cases that you will move from Oracle to Databricks. And because you will have established this list of business case, you will be able to prioritize them and build priority list P0, P1, P2. In the case of a lift and shift, you will take the existing business cases and you will migrate them one by one according this priority list. But if you have new use case you want to add during the migration process that will make a modernization process, you will be able to add this new business case into your priority list depending on various parameters. For example, in this example, the new business case one can be dependent on this first business case one. So by doing that, you will be able to maximize the ROI by defining the priority list. Okay, so you will deliver the highest value for your business as soon as possible. You will minimize risk because you will repeat the stuff in a kind of industry process. You will migrate everything the same way. And you will also minimize the time to migrate because you will apply on top of this, each of these business case will be migrated to Databricks following the same migration strategy. We recommend to use the same migration methodology because it will make this migration process something repeatable, some kind of industry process that will give you confidence on the way to migrate your assets from Oracle to Databricks. So in terms of migration strategy, at Databricks, we have two main migration strategies. We named them ingestion and ETL first and BI first. So what does it mean? So first of all, the ingestion in ETL first. So this one can be recommended, for example, if you want to modernize from scratch. You will recreate all the ingestion, the ETL process, and so on. Or if you want to use something that is natural to migrate because you will open up a new branch here from data sources, you will add them into the lakehouse. Then you will import the integration layer that lives within your data model, for example, as an initial load in the bronze area. Then you will recreate, you will migrate your ETL process to create this new integration layer directly into the silver layer. And at the end, you will create the serving layer, the data marts, that you will expose to your end user. You will build the UAT, you will test it from a business perspective, as well as technical validation. And this technical validation is usually what we name the data reconciliation process. And it's done at the end, but also during the creation of this layer. And what does it mean, data reconciliation? We will check that the data created is the same as on the original, on the source platform. We will validate some indicators like aggregates, averages, and so on, to validate that we have the same consistency. And of course, at the end, we will validate that for a business perspective, we have also the same consistency. And when all of these tests will be done, we will be able to decommission the legacy platform and use Databricks as it is. So this one, as I mentioned, is perfect if you want to be focused on the most complex part of your migration, which is usually the ETL part. But on the other hand, you have also the BI first methodology. The BI first methodology is roughly the same, but just a little bit different because we will migrate first the data marts to Databricks as a source. We will copy this data source as it is from the bronze directly to the gold layer. And then we will be able to present this data to our business lines and say, for example, if you want to implement Genie, or if you want to implement data products on top of your data marts, and this could be part of the use case, you will provide this value directly to your final users at the beginning of the migration process, okay? Because the previous one is something that could take some time to bring the value directly to your customer while you will spend time on migrating the ETL. Here, it's not the case. But once the data mart has been migrated to Databricks, we will do the same as previously. We will create the data source. We will make the initial load, create the integration layer, build the data marts, and once we will be at this stage, we will compare all data marts. Are they the same? Yes. So if they are the same, that's a good point. Are they delivering the same business logic? Yes. So perfect. We will validate everything from a technical consistency as well as the business consistency. And once it will be validated on both sides, we will be able to decommission the platform and then migrating. And these methodologies, so BI first and ETL first, will be applied for every business process, business case, sorry, that you've identified during the initial inventory. This will make the migration process something kind of bit automatic. Okay, so next section on the challenges which are specific to Oracle. Oracle, as Ali mentioned it this morning, is a closed system. You may know that, like me, you have these data files, you have this table space, you have this table of materials view, and it's really hard to move this data out of Oracle to something open like Databricks. But you have some capabilities to do that. And in this slide, I split it into two parts. The first one is the archive data or non-living data, because we know that in every data warehouse we have archive data, which are not used very often. And we have what I name living data, which are recent data ingested and transformed. And the way you will migrate them out of Oracle to Databricks could be different and using different methods. So the first one for archive data, if you are using an Oracle on-prem instance, 19.9 plus, and on a cloud deployment as well, you will be able to use the DBMS cloud package and the export data function that will help you to export data from table to various formats, could be CSV, JSON, or Parquet. You can also export data using SQL Developer. So SQL Developer is an Oracle client tool to query your database. And there is an offload function on SQL Developer that will help you to offload the data to CSV and then import them into Databricks. You can also write your own script. So you will spool the data into a CSV file. And once this data is exported, you can transfer them, depending on the volume, to the cloud. Because when you migrate, for example, an on-prem database, you have also to consider the data volume that you will bring from your servers to the cloud. And when it's a concern of hundreds of terabytes, it's a real concern. And for that, you can rely on data transfer solution, for example, AWS Snowball or Azure Data Box, to transfer your data from your servers to cloud data centers. And once it's done, you can load the data by using various functions, features of Databricks. It could be autoloader. It could be the load from file option available in the UI of Databricks. And last solution is to use delta sharing, especially if you are using Oracle in their autonomous database option, because Oracle decided to use delta sharing as a sharing protocol. That means that between Oracle Autonomous Database and Databricks, you can use the delta sharing protocol. For the living data, you can use Lakehouse Federation in a way, because it will not. Lakehouse Federation is a good fit if you want to transfer data, for example, for your data mass, because the data volume won't be very important. You can also use PySpark and JDBC connection directly to your Oracle database and execute some merge statement that will, on a daily basis, ingest the delta between what has been imported previously and the daily jobs. You can also use Azure Data Factory, Amazon DMS, to connect to your Oracle instances and move the data to Databricks. And finally, you can also use various solutions coming from our partner ecosystem, Click, Talend, and Fivetran, especially, for example, if you want to use CDC-based connection. Fivetran has a tool named HBR that do that very, very well. Okay? So this, first of all, the data migration, you have lots of tools that you can use, and depending on the case, depending on lots of parameters, you can use one or another. Then in terms of challenges, you have also the data types challenge. Oracle data types are not the same as in Databricks, especially, for example, numbers to decimal. Number rely on precision and scale, which are not the same. And so depending on the precision, depending on the scale, it could be a challenge to migrate this. And so beyond the limit of the scale and the scale of decimal in Databricks, you will have to convert it to double precision floating number. Character set conversion can be also a concern, because in Oracle you have multiple ways to use various character sets. At Databricks we use only UTF-8. Timestamp and dates can be also a challenge. You have also some data types that are not existing on Databricks B5, for example, or raw ID. So if you use that, it will be a very complex things to address, especially for raw ID, which is not a recommended use for Oracle. And also for semi-structured data types, JSON and XML type can be converted into variant on Databricks. User-defined types, yes, this is also a concern because you will create kind of objects, and these objects can use data types, but also code, functions, and procedures that you will have to convert. But we have a solution for that, and this solution is named LakeBridge, formerly BladeBridge. And BladeBridge is made of various solutions, and the one that will be very interesting to convert your code will be the code converter. And this code converter will support the code conversion from Oracle to Databricks, and it will support DDL conversion as well as PL SQL to Databricks. And the target is to use Databricks SQL. For PL SQL, the target will be to convert PL SQL to SQL scripting. You have here a basic example of what could be converted from Oracle to Databricks. It's not the same language, but it's totally doable. And LakeBridge will be able to support this code conversion. And you have some topics that will require more effort to be converted. Especially, for example, you have lots of stored procedure function PL SQL packages that use intensively all of these supplied PL SQL packages. They are usually named DBMS something, UTL something, CTX something. And for all of this, we don't have parity because they are packages supplied by Oracle. So if you have this in your code, that means that you will have to retro-engineer the code and write something that will be compatible with Databricks. And the final one is the external libraries. So the thing I mentioned at the beginning of this presentation, in Oracle, you can write your routines using C or C++ language and put them into external libraries. So on Windows, they will live into DLL files, or on Linux in .so files and so on. And because these are compiled code, you will, if you want to convert this to Databricks, you will have to get the code, read the code, and convert the code. And because it's usually based on C or C++ routines, LakeBridge doesn't support C or C++ conversion, so you will have to do it manually. Okay, so in the next part of this presentation, I have recorded a quick demo of what LakeBridge looks like. So currently, this is the former version of LakeBridge named BladeBridge. It will be changed in days, I would say. I hope tomorrow you will attend the keynote. So in this first part, I will extract the code from my Oracle database, and I will be in the case of I want to implement a BI first. That means that I will target my data marts. I will export the code, okay, from Oracle. I will convert the code, and this converted code will be pasted into Databricks to create the data mart structure. This will not, this demo will not show the data transfer, but it's just for the sake of the demo because we don't have a lot of time. So I connect to my Oracle database. Then there is 3 data marts. There is 3 simple data marts. So in the next calls, we'll format the output. Okay, so we will use here in Oracle a package named dbms metadata to extract the DDL. And then we will run this dbms metadata get DDL for every tables that will extract the code of all of these tables. And we will paste the generated code to files. And these files will be converted by BladeBridge. So I use the script here. So in this example, I have 4 files, okay? And you can see the contents. It is the same that has been generated previously by the dbms metadata. Same for this mapdo.sql. And then I've added another table to show you the difference between the numbers that we can convert depending on the scale on Oracle to decimals. And here, for example, column C and column D, this is not possible on Databricks because here we have a scale that is greater than 38. And here we have a negative scale. That means that this number will be rounded at the hundredths of its value. Then we will run BladeBridge. So BladeBridge here is a command line tool. And we provide the input directory, the output directory, and a configuration file. Oops, sorry. That will generate the code converted. And at the end, as you can see here, my data mart has been converted into a syntax that is compatible with Databricks. Numbers have been converted to decimal. varchar2 have been converted to strings, and so on. And if I look at my test number table, we can see that the column A and B has been converted into decimal following the precision and scale which are compatible with Databricks. And for the one with the scale beyond than 38, it has been automatically converted into double. And the one that has been with the negative precision, it has been converted to kind of integer because this is the way it will be converted to negative precision. And so I think the rest, so as you can see here, I will copy the code generated, and then I will paste it into Databricks, run the code, and it will create the table structure. And once converted, I will just have to transfer the data from my Oracle to Databricks by using, for example, a JDBC connection or a Lakehouse Federation connection. Okay. So, what are the benefits of migrating Oracle to Databricks? There are multiple. The first one is the TCO reduction. We all know that Oracle solutions are really expensive in terms of hardware, if, for example, you use Exadata, as well as license. So you will eliminate, for example, hardware cost because you will move to the cloud. You will reduce software cost because you will pay for what you use and not pay for license plus enterprise options plus packs plus all the options available on Oracle. You will also lower administrative cost. What does it mean? I have been DBA in my previous life. And DBA, for example, if you want to tune a query, you don't have any AI, for example. You don't have this predictive optimization that we have into Databricks. We don't have indexes. And if you know Oracle, you have these B-tree indexes, function indexes, reverse key indexes, bitmap indexes, lots of indexes, and each one of them can be used in various use cases. You will not need that into Databricks. You will use liquid clustering, and that will be fine. And I have lots of examples on that. You will improve scalability and performance because you will be able to scale up at levels of hundreds of thousands of nodes, which is not possible, for example, with Exadata. And you will be able to scale up and scale down the performance and pay for the level of scalability that you will have chosen. You will be able also to enhance data science and modern analytics capabilities. For example, if you want to implement classification ML, if you want to implement GenAI, for example, you will be able to do that with Databricks. With Oracle, they will tell you, oh, move to OCI and use this OML package within OCI. But OML package means Oracle ML. That means that you will continue to be software locked. Your governance will be simplified, especially if you decide to use ML and GenAI, because you will be able to govern your model the same way you govern your tables, your columns, your rows, and so on. And you will be able to implement faster time to insight and decision making, because, for example, implementing real-time ingestion and at the end, real-time decision-making process will be a real concern in Oracle, because you will have to ingest data coming from Kafka queues to temporary tables and trigger ETL processing and so on. And it will take more time if we compare it to Databricks because of Delta, because of our native connectivity to that kind of queues. So this is one of the last slides that I have for you today. And I have another one. So if you want to know more and more details about the strategy that I've presented, you can scan this QR code. It will redirect you to a form to download this ebook on how to transform and to migrate your legacy data warehouse to Databricks. Oracle can be is addressed in this document, but not only. Teradata as well, SQL Server, and all these legacy technologies. And we recently released a couple of resources. You will find them into databricks.com/resources. And these guides are technology specifics. And in that one, you have this Oracle to Databricks migration guide that will give you all the details and some examples on how to convert objects to Databricks. And you have the same for Teradata, Microsoft SQL Server, and Netezza. So we are at the end of the presentation. 1 minute left on time. So sorry, I know that it's a lot of QR code to scan. But this one will redirect you to a set of resources if you want to continue your learning journey by using Databricks. And last slide on the survey to give some insights of what you are thinking about this presentation. I thank you all. If you have any questions, I'm sorry we are short in time, so 30 seconds. So if you have questions, I can take them after this presentation. Thank you.